So in the previous video's continuation, as the spring one is moving to the left side from the equilibrium position and it stops, and means maximum when once it gets maximum compression and it stops, and then it will spring back to the equilibrium position. So as it stops to the left side, it will get the maximum displacement and maximum potential energy, and kinetic energy will be zero. Same here to the right side, when it stretches the maximum at most, it will get the potential energy, the maximum kinetic energy will be zero. Okay, the next, as the mass moves towards the equilibrium, spring force and velocity point in the same direction. Kinetic energy increases, potential energy decreases. So what they are telling here, now it is compressed and it is moving towards the this is an equilibrium position. E means equilibrium position, and the spring one, as it is moving towards the equilibrium position, the spring force velocity in the same direction. Spring force and the velocity in the same direction. If it is in the same direction, kinetic energy increases, potential energy decreases. So just it is opposite when the mass moves away from the equilibrium. If this mass is moving away from the equilibrium to the left side, means getting compressed, spring force is opposite direction of the speed, which means kinetic energy decreases, potential energy increases. So very important point. You can pause the video and you can write it down. After one full period, which means it moves from, this is equilibrium, go to left and come back to the equilibrium, and go to the right and come back to the equilibrium. This is called one full period, one cycle. The mass returns to the same position, the same energy distribution. Now once it reaches, then finally mechanical energy will be the same, will be constant as it was before. Okay, for example, mechanical energy at the point at equilibrium is 100 joules. As it goes away from the equilibrium, all the potential energy will be 100 joule, kinetic energy will be 0. And when it is returning to the equilibrium position, kinetic energy will be 100 and potential energy will be 0. And when it is moving away from the equilibrium and reaches the top end, the highest displacement, potential energy will be again 100 joule, kinetic energy will be 0 joule. So whenever you add potential energy plus kinetic energy, the answer must be 100 joule at any point. At some point in while it is moving towards or away, if the potential energy is 20 joules, what is the kinetic energy? So you know it must be 80 joules, because 80 joules plus 20 joules is 100 joules. If the potential energy is 30 joules, what is the kinetic energy? 70 joules, because the mechanical energy is always constant. Now we have to learn the same, apply the same concept for the simple pendulum. You know, here is the mean position A and it is the maximum displacement position B and C. The total mechanical energy is constant. Kinetic plus potential energy of the simple pendulum, half mv square plus mgh. Mgh is the potential energy of the simple pendulum. At the extreme position is B and C. Speed is 0. It is not moving, it temporarily stopped. So all energy is gravitational potential energy. What is the kinetic energy at the point B and C? 0. At the lowest point means the point A, height is minimum. Height from the ground is minimum. So energy, potential energy is 0. Kinetic energy is maximum. Because as it is moving back to the equilibrium, here the speed is at maximum. So kinetic energy at the equilibrium is maximum. Energy changes back and forth between K and U, but total stays the same. Total energy is always the same, as we mentioned here. 80 plus 20 is 100, 30 plus 70 is 100. Same thing here. If potential energy is 100 joule, kinetic energy 0. Here potential energy again 100, kinetic energy 0. Here at the minimum, at the lowest point, kinetic energy is 100, potential energy is 0. In between any point, potential energy is 40, kinetic energy 60. Anywhere in between, potential energy is 10, kinetic energy is 90. It maintains the total energy the same, 100. Now you can memorize this concept for the Hooke's law and for the simple pendulum, for the spring and the simple pendulum. Maximum displacement, all potential 0 kinetic. Equilibrium, all kinetic energy 0 potential. Moving towards equilibrium, kinetic increases, potential decreases. Moving away equilibrium, kinetic decreases, potential increases. But at any point total mechanical energy is constant and the pattern repeats every period. You can pause and you can copy it. Now we have a question related to this. Here is the equilibrium and it is stretched by 2 centimeters, stretched by 4 centimeter. Now we are comparing the spring 1 energy, spring 2 energy. Spring 1, half k x1 square. Spring 2, half k x2 square. K is constant because the same spring we are using. So you can cancel k, you can cancel half and half. So when you divide these two, finally you will get x1 square, x2 square. Apply the value of x1, 0.02, because 2 centimeter changed into meter, 0.02. Now using calculator you will get 1 by 4, and when you cross multiply, the spring 2 is equal to 4 times spring energy for the spring 1. Okay, if you stress the spring 4 centimeter, your spring energy is 4 times greater than the spring energy for U1. You can pause and you can write it. Next question, determine what effect period of simple pendulum. Okay, simple harmonic motion for small angles only less than 15 degree, because restoring force is proportional to the displacement. So now you have a simple pendulum. You can make a 15-degree displacement and leave it, then it will follow simple harmonic motion. If it is more than 15-degree, it will not obey simple harmonic motion because it no longer force proportional to displacement. So if you want to maintain the force proportional to displacement, the angle of displacement must be less than 15-degree. Okay, that will affect the harmonic motion. Velocity and force. At maximum displacement, restoring force is maximum. Velocity is zero. As I told you before, the spring force is maximum. Velocity equal to zero. Kinetic energy is equal to zero. Potential energy is maximum. You can pause this video and copy. At equilibrium, restoring force is zero. Velocity maximum. Kinetic energy is maximum. Potential energy is zero. You know the formula 2 pi square root of length L by G. Very important thing is this one. What does not affect the period? Mass of the bulb. The mass of the ball. Now we have a bigger mass of the ball. Ball is a bulb. And we have a smaller. And the length is example 50 centimeter length for both. And you are measuring the time period. And this time period value for the bigger metal bulb is equal to the smaller metal bulb. It will not change. Even though the mass of the ball is different, time period is the same if the length is the same, a constant length for both. You can pause and copy it. Question number 5. Differentiate between transverse, longitudinal, surface waves and give examples. Transverse waves, particles move perpendicular to wave direction. So this is a transverse wave, and right side is the wave direction, the wave motion, and the particles move up and down. So it is like this, up and down, and it makes 90-degree to the direction of wave motion, and 90-degree is called perpendicular. Wave travels horizontally. See, wave is traveling horizontally, particles are moving up and down. Travel through solid, liquid or string. Example, light wave, wave on a string. You can pause and copy. Now we discuss about longitudinal wave. Particles move parallel to wave direction. Now you have a spring, and if you want to make a longitudinal wave, you move the spring forward and backward, and the particles are moving forward and backward from the mean position, and the direction of wave is moving forward. So if you see, the motion of the particles are parallel to the direction of wave motion. So that's what they say, parallel to the direction of wave motion. And it has the compression and rarefaction along the way. Travel through solid, liquid and gas. Example, sound wave, spring, compression wave. You can copy by pausing the video. Surface wave. It is a combination. It is the combination of transverse and longitudinal. It has both transverse wave and longitudinal wave. The surface wave has. And the particles move in a circular or elliptical path.